This demo is doing data preparation and feature engineering on the 200 gigabyte Fannie Mae single-family loan performance dataset in preparation for training an XGBoost model. The query itself is pretty standard PySpark. There are two queries here, one for each cluster, the GPU cluster and the CPU cluster. They are identical except for the location where we store the intermediate data so they don't collide, and a couple of configs to tune each query optimally, either for the CPU or the GPU. The GPU cluster is on the left with a V100 GPU on each of the nodes. The CPU cluster is on the right. These queries take quite a long time to run, so we're going to get them started. And then we can explain more information about the setup as they're running. We'll start the CPU first to give it a bit of a head start, and then we'll start the GPU. Now, we're ready to do the processing. First, we'll transcode the data from CSV into Parquet. The reason we're doing this is to reduce the total size of the data from 200 gigabytes of CSV into about 16 gigabytes of compressed Parquet data. This will decrease the amount of data that we have to load as we process from S3, speeding up access time and speeding up the query. The data is originally stored in S3. We've just mounted it under the Databricks file system here. This also allows for predicate pushdown. Parquet is a columnar format. It stores the data for each column separately. And so in this complicated query where we do all self-joins several times, it can reduce the total workload, the total amount of data that we have to read by a significant factor, because we only have to read the columns that we care about. Now that the GPU job is completed, let's go take a look at the Spark UI for the GPU cluster. We have integrated all the GPU changes pretty seamlessly, and it should be intuitive. On the SQL page, you can see that we have the same type of boxes, the same type of events that you would expect on a Databricks UI. Same with the normal Apache Spark UI. We have even integrated all the metrics that you would expect on each of these boxes. There are also metrics there that are GPU specific. It's going to be quite a while before the CPU cluster is finished, so to avoid you getting bored, let's jump straight to the results. The V100 GPU ended up being a little over 4 times faster than the CPU, taking almost 7 minutes versus a little under 29 minutes on the CPU side, with a cost reduction of 25% over the CPU. Shortly after we recorded this demo, Databricks began supporting the NVIDIA T4 GPU, which is price and performance optimized for SQL processing. With T4, we've been able to provide nearly 4 times speedup over CPU at a cost reduction of 50%. To learn more, download our ebook, Accelerating Spark 3, today.